So this is the first part of first lecture, which is based on introduction to limits. So we will study functions and graph in this topic, limit of graphical approach, limit and algebraic approach, and limit of difference quotient. So limit of algebraic function is, like for example, we have a very simple function f of x equals to 2x minus 1. We can substitute any value of x. For example, if I substitute x equals to minus 2 into this function, we will get y or f of x equal, now sometimes we write it as y equals to 2x minus 1. Y is minus 5. If I substitute x minus 1, I will get y equals to minus 3, so on. If I substitute x equals to 1, I will get y equals to 1. But what we want to know that, for instance, let us assume that we don't know what is the value of this function at x equals to 2. What is the value of this function at x equals to 2? We have no idea what is this, but we know what is the value at x equals to 3. We can substitute x equals to 3 and we can get a number, whatever the number is. For instance, it is 5. So what we do, we will approach towards 2 from the left side, like here it is 2. We will approach towards 2 from the left side and we will approach towards 2 from the right side, and we will try to estimate what is the number. For example, we know that if we substitute 2 here, the number is 3. So let's see that how we can estimate this 3. For example, we are approaching towards 2 from the left side. We are very close to 2, but we cannot substitute 2. Likewise, we are approaching towards 2 from the right side, but we cannot substitute 2 because we have no idea what is the value of the function at x equals to 2. So correspondingly, when we are substituting x equals to 1.999 into this function, we get y or f of x equals 2.998. Likewise, when we approach from the right side, we substitute number very close to 2, but we are not substituting 2, and we are getting that it is 3.002. So on the basis of these two numbers, we can assume that, we can estimate that the number, whatever number comes here, it would be somewhere around 3. It would be somewhere around 3 or 3. And in actual, if we substitute 2 into this function, the number is 3. So it means our estimation is correct. So that is why we are calling it limits. So we tend to approach some numbers, but we cannot substitute accurate that number. So here you can see some examples. The concept is very strong. The whole calculus is based on this function or on this topic, like related to limits or continuity. But when we solve problems, it is very simple. For example, here you have a function and x is approaching towards 2. This sign means that x is approaching 2, but it is not 2, very close to 2. So if we substitute, but we will substitute x equals to 2 into this function. If we substitute it, we will get answer 3. So this is how we write the definition of limit. Limit x goes to c into this function, and result is L. This L is called limit. This L is called limit of that function at x equals to c. So one-sided limit, when we approach, like I gave you an example, when we approach towards 2, we call it left side or left-handed limit from the left side, and we approach towards 2 from the right side, we call it right-hand limit or right side. How to denote it? We simply write negative on top of the 2, but it doesn't mean that we substitute negative 2. We will substitute 2 into the function. Likewise, we write 2 plus when we approach from the right side, but it doesn't mean that we substitute 2 plus something, but we will substitute 2 into the function. Like we have seen that when we were approaching towards 2, we were writing here 1.999. When we were approaching towards 2 from the right side, we were writing here 2.001. So in reality it is 1.99, but mathematically when we will write it, we just to denote that we are approaching towards 2 from the left side, we will write negative at top of the 2, but in actual we will substitute 2 into the function. So you will see later on in coming examples that how it works. For example, here you can see that we are writing x goes to 2 from the left side, so the value of the function is 4. When we approach towards 2 from the right side, the value of the function is 2. Here we have a constant function, so it will not change. If you have variable function, then it will be even more clear to you. So limits property L, if L is equals to M, then we say that the function is continuous. So here you can see some more examples related to limit. Limit x goes to 2, we substitute 2 into this function, and you can see we can apply limit on this function separately, and we can apply limit on this function separately. This is just wastage of time. You can directly substitute 2 into the function and you can get the answer directly. Likewise here, we substitute 4 into the limit into the function. Wherever we have x, we can substitute 4 and we can get the answer. So when you solve the problem related to limit, one thing you should be consider, like for example, it should not be 0 by 0 form. For example, I write here limit x goes to 2, x square minus 4 over x minus 2. Now here you can see if I substitute 2 directly, I will get 0 by 0 form. So we have to avoid this form, and in order to avoid this form, we need to do some algebraic calculations, and to do that calculation you will need these formulas. A square minus b square equals to a minus b times a plus b, and there is another formula you may need, a cube minus b cube plus or minus, so it is equals to a minus b. If it is plus, it is plus. If it is minus, it is minus. Then a square minus ab plus b square. If here it is plus, then this will be minus. If this is minus, then this will be plus. So we will solve some examples when we will solve this topic. Okay. Like here you can see that as I said earlier, we need to avoid this situation 0 by 0. So if I substitute x equals to 2 directly into the function, I get 0 by 0. But if I do some algebraic calculation, like as I said, x square minus 4 can be written in this form, and x plus 2 times x minus 2, and this x minus 2 will cancel out with this x minus 2. If this cancel out, we get x plus 2, and we can substitute easily and we can get the answer 4. Apparently the answer was 0 by 0, which is undefined form in mathematics, but when we do some algebraic calculation, we can get 4. So we will discuss later this topic, difference quotient, but for now we can keep it up to limits, and I will solve some more examples for you and I will upload those examples.